This is the lab video that goes with the chemical reactions lab. A completed lab will include the pre-lab, recording of the observations shown in this video, and then balancing the chemical equations for the reactions that are demonstrated. There are no post-lab questions in this lab. The balancing the equations are counting for the post-lab questions. So in this lab, you're going to be introduced to 4 different types of reactions. We'll start with combination reaction. And in a combination reaction, it is when 2 elements combine. You can see the word combine in combination. So we'll have 2 different substances, and they will come together to make one substance. We'll also do a decomposition reaction. And you can see in the name of decomposition reaction is the decompose, which is breaking down. It's kind of the reverse of a combination. We'll start with one chemical and we'll break it down into its pieces using a Bunsen burner. And then we have several single replacement reactions. And in single replacement reactions, you have one substance that is by itself, so it's just in an elemental form. And then it is going to react with another substance, and the single substance kicks out one of the components of the other one. So in this case, A kicks out B, and so now B would be single, and A replaces B, and is now with C. And then we have a double displacement series, or double replacement. Either one, displacement or replacement, are acceptable. And in double displacement, we have a switching of partners. So we have ionic compounds, and so they have both a cation and an anion. And they switch partners. So A is going to form a new partner. Oops, I have too many. See a mistake. This should be CD. There we go. A is going to form a new partner with D, and C will form with B. So A will go with D, and C will go with B. So they switch partners, and that's double displacement. And so we're going to take a look at reactions in each one of these categories. So the first reaction was combination. And so step 1 is we had a copper foil. So we're reacting copper. And then step 2 said light a Bunsen burner. And so here's the Bunsen burner here. It's hard to see the flame, but the flame is there. And then holding the foil with tongs, you can see here's the copper foil with tongs, into the hottest part of the flame and write your observations. So this is step 3. Now look at the copper wire. Can you see the green color? And that is the copper oxidizing in the air. It's heating the copper and the electrons, and so we see a green flame. And then afterwards, these are our observations. Afterwards, you can see this is where the copper was in the flame. It's a little more, it's dull, and it turned kind of a dark grayish color, comparing it to where we started with. So you need to record the observations that you see in the pictures. How would you know that a reaction happened? What did you see? And the combination, what we're doing is we're reacting the copper with the oxygen in the air. And the heat is there to help the reaction occur. And it's making copper with oxide, copper 2 oxide. So this is the equation you see in your data sheet. It is not balanced. You're going to have to balance it. At the end of the lab, I will balance one of the chemical equations just to help remind you. Now, the second type of reaction was a decomposition reaction. And this one is kind of fun because it gets to use something called a glowing splint. And glowing splints are used to indicate if there is oxygen being released from a reaction. So you get a piece of wood and you light it on fire and then you blow it out so there's no flames, but it has a little ember there, a little glowing. And if you stick it in the presence of oxygen, it catches back on fire. And so that tells us when oxygen is there. If there is no oxygen, it will not catch back on fire. So we're decomposing potassium chlorate, which is KClO3. And it requires heat, so again, I had to use a Bunsen burner. So in this first picture, this is the potassium chlorate, and you can see I put a very small amount of it into a test tube. And so this is step 2 in the procedure. I was holding the test tube and heating it carefully in the Bunsen burner. There was no one else in the lab, so I wasn't pointing it at anyone. Then it says use a glowing splint to detect the presence of oxygen. So if you look right here, let me change the color so you can maybe see what I'm circling on this picture. If you look right here, I had lit over here, on the second picture, I had lit a wooden stick on fire, and so in this third picture it was glowing. So you can see a little ember at the end of it. And I'm getting ready to place it, not drop it into the test tube, but just place it into the mouth of the test tube. So this is the first part, I'll say 3A. I'm placing it in. And then this is 3B. So then notice, look carefully, once I put the splint into the mouth of the test tube, it reignited and caught on fire. And that's telling me that as part of this reaction, oxygen is being released. And if it's hard to see from this picture because it was hard to take a picture close up and do everything, but here the potassium chlorate is no longer a white powder. It was kind of bubbling and clear. So it started to melt and it was bubbling. And so what's happening, and this is the equation you have on this part of the lab, is it was decomposing to potassium chloride. After I allowed the test tube to cool, there was a white solid in the bottom. Not as much, but a little bit of white solid. And then I know I was giving oxygen off, not because I could see it, but I did observe bubbling, and the glowing splint tells me oxygen was coming. Now again, that equation is not balanced, but this is the equation that tells you what the different substances are. And so the next set of reactions are single replacement reactions. Remember, you're recording your observations as to what you see in the reaction from the pictures. And so there were 3 test tubes, and in general what happens is you're going to see we have something by itself, and I'm going to put it So here's all the things by itself. These would be like the A's. And then here, these are all my BCs. These have two things in them. And so what we're going to observe is when one of the things that are together come off, and then A goes with C. So let's take a look at these. So this is the first one, and down here I have zinc. It's a little silver colored metal, and this is called a pellet. It can come in different shapes. And the directions told me to add it to HCl. So there's my BC. And what I observed, these are my observations, is a lot of bubbling. And it's hard to see, but the little pellet is starting to dissolve. You can definitely see the bubbling. So what the bubbles are hydrogen gas. So zinc is causing the hydrogen gas. It's replacing it. So the hydrogen gas is coming out, and hydrogen's a diatomic element, so that's why I have two of them. And then zinc is dissolving and becoming zinc chloride, and it's dissolving in the solution. The second one is, this one is one of my favorite. I have copper metal, and you can see it in the test tube, similar to what we used for the combination reaction. And I added it with silver nitrate, and silver nitrate is a clear and colorless solution. I'm just going to write here, this guy is clear, which means it doesn't have any particles, but it's also colorless. And in this reaction, the copper is kicking out the silver. And so I have silver. And do you see the flaky like hair that's silver colored? That is silver. Looks cool. And it is coming out and forming the copper nitrate. So copper nitrate. Now, here's an observation. If you can see here, the solution is starting to turn blue. That's because copper nitrate is blue. The third reaction is iron metal, and this just looks like the Brillo pads. So you had iron, and then I'm adding it to copper chloride. Now notice the copper chloride is still clear. It doesn't have anything in it, but it is a blue color. And so the iron replaces the copper. So the copper comes out, and do you see, this is really cool. That red on top of the iron is copper. So what you're seeing is the red copper on the wires. It's coming out of the solution, and then we make iron chloride. Now, the solution starts over here very blue, but if you look here, it's starting to turn clear or colorless. That's because the copper nitrate is the copper chloride is a blue solution, but iron chloride is colorless. So as the iron chloride is forming, the solution's changing to colorless. So those are 3 single displacement reactions. And then for the last part of the lab, we're doing 4 double displacement. And double displacement are when they're switching partners. So if you notice over here, this could be your A, B. See how there's 2 things for each one? And this is your C, D. So let's look what happens. Here I have sodium chloride and silver nitrate. And when they mix, and this happens instantaneously, I get this white milky solution. So when they switch partners, sodium nitrate is still a solution. So that's the liquid, and it's colorless. So that we don't really see. But silver and chloride, when they switch partners, so sodium goes with nitrate, and that's a colorless solution. Silver goes with chloride, and that is a, that is a solid, and it's white. So that white cloudy that you're seeing here, the cloudy, that is silver chloride, and it's a solid. And the liquid part is sodium nitrate. The second reaction, well, we do see here you're starting with a blue solution, and this one is a colorless solution. Clear, again, describes when there's no particles there. So this has copper nitrate, which again is a solution that's blue. It's aqueous. And we're adding it to the sodium hydroxide. And if we're thinking about what's happening, it's switching partners. So copper is going with hydroxide, and sodium is going with nitrate. So the copper with the hydroxide is a solid. And you can see it looks like a gel. So that's the copper hydroxide. It's forming a solid type substance. And then sodium nitrate, this is just a clear, colorless solution. So the solution that is around it has sodium nitrate inside of it. So they switched partners and formed that blue copper hydroxide. And it happens instantaneously as soon as the 2 liquids touch. The third reaction is lead nitrate, which is, this is the lead nitrate, and it was colorless. And then potassium chromate. And this is a clear solution, but it's yellow. And when you mix these 2 things, they switch partners. And the lead goes with the chromate. The potassium goes with the nitrate. And what happens is the lead chromate forms a solid. And if you look here or you look there, and if you let it sit for a while, the solid settles. But that yellow color is a yellow solid. And that is the potassium chromate. And when you react it, and then what's left, the potassium goes with the nitrate. And this is in the solution, which remains colorless. Now, it's kind of hard to see when you first mix it because the yellow solid is so powdery. It doesn't like to settle. It's just floating all around. But if I would have let it sit there for a couple hours, the yellow solid eventually would sink to the bottom and leaving the solution, the clear kind of colorless solution. But it's very a fine solid, so it kind of just swirls and hangs in the solution. And then finally we added a sodium hydroxide, which you can see here is clear. There's no particles in it, and it's also colorless. And hydrochloric acid, which is also colorless. And when they switch partners, Na goes with Cl and H goes with OH. And so NaCl, this is sodium chloride, and it just stays dissolved in the solution. And then H with OH, that makes water. And so when you look at what happened in both cases, and in the bottom, this may look like there's solid, but there's not. I think it's just the test tube reflecting. This had nothing in it. It was still clear and colorless. So if I was only using my eyes as the observations, I would have thought that nothing happened because I mixed two clear and colorless solutions and it made a clear and colorless solution. But if you can see my poor finger there, which is all dry from washing my hands so much, when I touched it, it felt warm. So there was a change in temperature, which let me know that something had occurred in that test tube. Because just visually, I didn't see changes in color like I had on the rest of them. But this is an acid-base reaction, which we talked about in a previous chapter. And sometimes you can't see it visually what happened, but oftentimes when you react an acid and a base, they can give off heat. Now that's the end of the observations, but I would like to balance one equation just so you remember. So there's not post-lab questions in this lab. What you're doing is you're recording your observations in the boxes, and then you're going to balance all the equations. And the balancing of the equations is what counts as your post-lab questions. So one of the first things we did was we added copper to oxygen, and it made copper oxide. So remember, the law of conservation of mass says that we have to have the same number of each type of atoms on both sides. And so I want to balance the equation. So I need to be sure that I have the same number of coppers and the same number of oxygens on both sides. So I start out with 1 copper and 1 copper. Then I would look at the oxygen, and there's 2 oxygens here, but there's only 1 oxygen here. So in balancing the equation, I would put a coefficient of 2 here. And that will multiply to my oxygen and change my oxygen to 2. Now when I added this 2, it also impacted the copper that it was in front of. So that changed my copper to 2. And so to complete the balancing, I would write a 2 in front of this copper. So this would be the balanced equation. Now I will give you some confidence if you end up getting that there's all the coefficients are 1, meaning when you count it out, it's already balanced. There are several reactions in this lab that all of their coefficients are 1. So when you count up each of the atoms on both sides, they will be equal without adding any coefficients. Well, I want to congratulate you because this is the last lab that we had to do, and I am just really proud of you for making the transition during this hard season. So good work for completing your labs.